Assalamualaikum warahmatullahi wabarakatuh. Today we are going to talk about the gravimetric analysis. So, what is gravimetric analysis? It is a highly accurate and precise method used to determine the amount or concentration of a substance by separating the analyte from the sample. The process of gravimetric analysis including filtration, washing, drying, and weighing. The mass of a formed compound is directly related to the quantity of the analytes in the original samples.
Now, let's look at its theory. Gravimetric analysis is a method used to find out how much of a substance called an analyte is in a sample. It works by turning the analyte into a solid compound and measuring its mass. Let's go through the key steps. First, the analyte is turned into a solid through precipitation by adding the right reagent under controlled conditions. Second, we ensure the precipitate is pure and fully formed. This prevents loss or contamination that could affect accuracy. Third, we control sources of error like unwanted ions, solubility issues, and also gases that might affect the weight. Fourth, the solid is washed and dried properly to remove any leftover impurities and moisture. Fifth, it may go through ignition where it is heated to form a stable compound for accurate weighing. Lastly, we do stoichiometric calculations using the measured mass to find out how much analyte was in the original sample.
These are the step-by-step of doing experiment for gravimetric analysis. Firstly, the set of number written on the label was recorded. Secondly, the plant food sample was weighed 3.59 grams using a weighing paper and transferred into a beaker. Distilled water was then added into the mixture and stirred the mixture until the sample dissolved. And number 4 is the insoluble material was removed through filtration. And then about 40 ml of 10% magnesium sulfate, 7H2O was added. Then another 100 ml 2 molar NH3 was slowly added, and while stirring, set it at room temperature for 10 minutes. Filter paper was then weighed accurately. And lastly, the weighing paper was folded to be put into filter funnel and the precipitate was added. The sample was washed using 5 ml of distilled water.
Now, let's look at the result of our experiment using the BioS microbial organic fertilizer. We were analyzing the phosphorus content in the fertilizer sample. According to the label, the phosphorus content should be 1.5%. We used 3.46 grams of the fertilizer sample in the total. After according the analysis, we obtains the mass of the filter paper plus the precipitate MgNH4PO4 is 1.72 grams. The mass of the filter paper alone was 1.04 grams. So, by subtracting, we calculate the mass of the MgNH4PO4 precipitate to be 0.68 grams. This mass of precipitates will be used in the next step to the calculate of the actual percentage of phosphorus in the sample. Now, for the calculation, we use gravimetric factor and also mass of magnesium ammonium phosphate to find the mole of phosphorus. First, we calculate the number of moles of magnesium ammonium phosphate using its given mass, which is 0.68 grams, and its molar mass of 137.288 grams per mole. This will give us 4.95 times 10 to the power of negative 3 moles. Since 1 mole of MgNH4PO4 contains 1 mole of phosphorus, the mole of phosphorus is equal to the number of moles of MgNH4PO4, which is also 4.95 times 10 to the power of negative 3 moles. Next, we find the mole of phosphorus pentoxide. Since each mole of P2O5 contains 2 moles of phosphorus, we divide the number of moles of phosphorus by 2. That gives us 2.475 times 10 to the power of negative 3 moles of P2O5.
Last part for calculation, the phosphorus content in plant is usually expressed in terms of P2O5. We calculate the mass and content weight over weight of P2O5 in the sample. Mass of P2O5 is 2.45 multiplied by 10 to the negative 3 multiplied by 1 for 1.94 is we got 0.35 gram. For percent mass, we divide 3.46 multiplied by 100, so we got 10.15%. To conclude, gravimetric analysis is a precise analytical technique used to determine the phosphorus content in plant food. By converting the analyte into an insoluble and stable compound, this method allows for accurate measurement based on the mass of the precipitate forms. This method includes several steps including sample dissolutions, filtration, precipitation, washing and drying. The mass of the final product directly correlates with the phosphorus content in the original sample is 10.15. So overall, gravimetric analysis is an effective approach for quantitative analysis due to its high accuracy and consistency and minimal requirement.